So part two is our introduction to conversions. We're going to be spending a lot of time this unit doing conversions, so you need to make sure you understand how to do them. So to start, we're just going to start with units that you're familiar with, and we're going to basically focus on the approach that you should take whenever you do these conversions. The answer in terms of what approach you should take is dimensional analysis. So you may or may not have seen this before, but I will tell you this is something you're going to use a lot next year in physics, so it is something that is worthwhile in learning how to do. And then you can apply it here in chemistry as well as next year in physics. So with dimensional analysis, what's really important is you make sure that you have whatever unit is on the top of one fraction goes on the bottom of the next fraction so that they can cancel. And the top and bottom of the same fraction need to equal each other. Okay. So when you do a conversion unit, you have to have the top and the bottom equal each other of the same fraction or else it's invalid. Again, these units should be what's going to drive your conversion. You want to make sure that you're focusing on the units so that you can make sure that you're doing your conversion the best and easiest way possible. They also can help you figure out what you should do next. Okay. So this first practice problem we're going to do is pretty simple. We're just going to learn the process. Okay. So you have 1450 apples. You need to know how many dozen apples that is. So the best way that you can do this is kind of working through dimensional analysis and learning how to do this approach. So the first thing that you're going to do with dimensional analysis is you're always going to write the number you start with. Okay, so in this case, we're going to start with the 1450 apples. And you just write it down. The next thing you're going to do with dimensional analysis, we're always going to multiply, so you're going to write a multiplication sign. And you're going to write a fraction here. Okay, now again, here's where this first bullet point comes into play. So whatever's on the top and bottom of this fraction have to be equal. Okay, but I like to use the unit that's right here to help me figure out what unit to write on the bottom. So whatever it says right here, I'm going to write on the bottom of the next fraction. So apples is going to go here as well. And the only thing we can really relate apples to is dozens of apples. Okay, and that's what that's asking us for in this question. And then we just need to put the numbers that go with these. Okay, so we need these to be equal to each other. So the only way we can have dozens equal to the number of apples is if we write out 1 dozen is 12 apples. And then from there, we're just going to do some simple division, because to solve these problems, you multiply across the top. So 1450 times 1, and then you divide by 12. Okay, so when you do that, you're going to get about 120.83 dozen apples. Okay, that's pretty simple in terms of the example we're going to be using, but it's going to get harder as this unit goes on. But you want to make sure that these units can cancel. So if you've got one on the top, one on the bottom, they can cancel, which means you're left with the unit that you want here of dozen, which is good to go. All right, let's look at another example. If 1 dozen apples is equal to 0.2 bushels of apples, and we know that 1 dozen apples also equals 2 kilograms of apples, we need to know the mass of 0.85 bushels of apples. Okay, so that means that we're starting with this number. We ultimately need to get the mass measured in kilograms. Okay, so you always start with the number that you have that you need to write out, which in this case is this 0.85 number. And always use your units because that's going to help you. So I'm going to write out the 0.85 bushels. Now we're going to set up multiplication. Again, whatever unit goes here should automatically be written down. Okay, and then you think to yourself, okay, using this problem, what can I relate bushels to? Well, the problem tells me I can relate bushels to dozens, so I'm going to do that. And then using that conversion factor in the problem, I know what numbers to write. So I can write 1 in front of dozen and 0.2 in front of bushels, which tells me those numbers are equal. So that's good. I can have these two above and below each other in a fraction. But now my bushels is going to cancel, which is good. I'm not done yet, though, because I need the mass. Right now I have dozens left. So I need to set up one more conversion. Again, whatever's on the top is going to guide what's going to go on the bottom. So dozens on the top, so I'm going to write dozens on the bottom. I look back at the problem, and I have dozens in kilograms that I can relate. If I look back at this problem, too, I know what numbers to write in front of them. So 2 in front of kilograms and 1 in front of dozen. So then to solve this problem, you do have these 3 fractions here, but our dozens do cancel. So 0.85 times 1 times 2, you do that on your calculator first, and then divide by 0.2 because the 1 doesn't really matter. Okay, so 0.85 times 2, and then divide by 0.2. So when you do that, you're looking at about 8.5 kilograms, which is your answer. Let's try one more together here. So if one apple has 8 seeds, how many seeds are there in 14 kilograms of apples? Okay, so we're going to use that same conversion factor that we had from the last problem, okay, because that's going to help us here. So that conversion factor from that last problem was 1 dozen is equal to 2 kilograms. We'll need that, okay? So we're looking at this question, okay, if one apple has 8 seeds, that's a conversion factor. We need to know how many seeds are on 14 kilograms of apples. So we always start with that number we're given, so 14 kilograms. Whatever unit's up top is going to come down. And I think to myself, okay, what can I relate kilograms to using the problem? I can relate it to dozens. So I'm going to write that. Again, looking at that conversion factor, I know I should put a 1 in front of dozen and a 2 in front of kilograms. All right, so now my kilograms cancel. So now I have dozens, so I'm not done because I need to get to seeds. So in the next step, again, whatever's on top should come down. So dozens goes here. Then I ask myself, okay, what would be useful to get to from dozens? Well, I know that one apple has 8 seeds, so if I can get from dozens to apples first, then I can use that conversion. And this is a conversion that you should easily know, right? 1 dozen is always 12 apples. Again, we're not talking about baker's dozens here, just regular dozens. Cross out the dozens because they cancel. One's on the top, one's on the bottom. Now we're in apples. We're not there yet because we need seeds. Again, whatever unit's on the top is going to help you figure out what to put on the bottom. And I'm going to put seeds on the top. And then I know from the problem, one apple is 8 seeds. So I'm going to write one apple is 8 seeds. Apples can then cancel, and I'll be left with seeds, which is good because that's what I want. So what I'm going to do is take 14 times 1 times 12 times 8 on the top. After I do that, I'll divide by 2. And I should get about 672 seeds. And that's your answer, and we're done.